Okay, all right. Well, let's jump in. We're going to talk about cubic functions tonight. We're doing basics. Even though we say basics, the questions that I've picked for you this evening are not necessarily completely straightforward. They're not the most difficult questions, but it's cubic function, either sketching, finding the equation of, etc., etc. All right, so in this particular question, they give us f of x equals x times x minus 3 squared, with f prime 1 equals f prime 3 equals 0, and f of 1 equals 4. Okay, so some of this information that they've given us here is perhaps a little bit cryptic. When we see f prime 1 equals f, prime 3 equals 0, what are they trying to tell us? What does that information mean? So Pinga's hot off the mark there, but unfortunately, Pinga, it is not the x-intercepts. Aha, Z, there we go. Okay, so it's the stationary points. Okay, so Pinga, can you see they've used f prime x, not f of x, it's f prime x. So they're saying the gradient where x is 1 is 0. The gradient where x is 3 is 0. Okay, so f prime x, they're talking about gradient. Okay, so we know that there is a turning point at x equals 1, and we know there is another turning point at x equals 3. Here, this is simply an input and an output. So when x is 1, y is 4. So that means they've given us the coordinates of one of the turning points. We know that it is 1 and 4. Okay, so Pinga and everybody else, okay, f of x is y output. F prime x is gradient. Okay, f prime prime x is concavity. Okay, so be very, very careful. All right, so maybe it was a little bit difficult to see. I'm highlighting the primes in purple. I don't know if that makes it worse or better. Maybe I should make the question a little bit bigger. Let's just do that. Maybe that's a bit easier to see. Okay, so f prime x is gradient. Okay, so here we know the coordinates to one of the turning points because they've told us when x goes in, y is 4. The first thing that they ask us to do is show that f has a point of inflection at x equals 2. Okay, now that's worth 5 marks. Any idea as to how we would go about answering this question? Any ideas? What should we do first, Matrix, in 8.1? Zedalia, go for it, Zedalia.
Hi, ma'am.
Hi, Zedalia. How are you?
Hi, Zedalia. How are you?
I'm good, and you?
I'm fine, thank you.
I'm fine, thank you.
I'm glad. Ma'am, I personally feel like we should first simplify the actual original equation of fx. And after we do that, then we get the first derivative, then the second derivative. And
Beautiful.
then,
Beautiful.
That's as far as I got, and I don't know. We have to substitute something into that, but I'm not sure. Oh no!
No substitution. No substitution. No, you've done a good job. Okay, so as Zedalia said, everybody, you're going to take f of x and you've got to multiply it out. You need to multiply it out because you need to derive it. Okay, you're going to take the first derivative and then you're going to take the second derivative. Once you've got the second derivative, the measure or value of concavity at your point of inflection is 0. So you're going to make your second derivative equal to 0, and you should get x equals 2 as your answer. Okay, everybody okay to try that on their own? Are we good to try that on our own, Matrix? Thumbs up, thumbs down? Yes? Okay,
Let's go, Zedalia.
Zedalia says yes. Cool beans. Off you go, Zedalia.
Yeah.
The rest of you, you should be able to multiply f of x out, first derivative, second derivative equal to 0, solve for x. Okay,
Especially for
go.
you who are actually writing tomorrow, this is like a good sort of an exercise, because definitely a question like this might come through.
Absolutely, absolutely. Okay, so, and again, the more work you do on your own, the better for you, rather than you watching me do it. Okay, off you go, matrix. Let's do 8.1, and let's see what you get. Okay, so everybody continue working. I'm just answering Pinga's question. All right, so Pinga, you would first need your x-intercepts. Okay. Once you've got your x-intercept, and you would obviously need your y-intercept as well, which you would get from 8.1 when you multiplied f of x out. So you first got to do the x-intercepts, and then you could go ahead and go and sketch the graph. Okay, so don't be shy. If you've done 8.1 and you want to go on to 8.2, do it. I'm going to work slowly behind you, and then you can check back with the answers. Okay. Cool, and Kani, so cool. And then, of course, yes, please let us know when you are done with 8.1 and done with 8.2.
Yes, please put it on the comments and say done when you're done. Like this, teacher Lee and I can know that you are done.
Absolutely. And the other thing you can also do is, just to not put anybody off, if you want to direct message me or direct message Yolanda, you can do it, either of us, doesn't matter who. If you want to share your answers with us, direct message them to us rather than on the chat. Okay. Well done on Tatile. Have you done 8.2 as well?
Yeah.
Modisa, let's just have a look. Modisa, you don't actually have to show the point of inflection on the graph. Okay, so when you sketch a cubic function, you've got to show the x and y intercepts and the coordinates at the turning point. You don't have to show the x and y coordinate at the point of inflection unless they ask you to. Okay. Okay, so Katlejo, look at my answers over here in pink. All right, I've multiplied out f of x. All right, so I'm going to put a pink. Did you get that when you multiplied out f of x? Then check my first derivative. Check my second derivative. Okay, so just compare your answers with mine, Katlejo. And see if you can find your mistake. Done. Okay, you found your mistake. Cool. All right. So there's another person done. No, it doesn't have to be to scale, Zedalia. That's fine. And Caniso's done. Okay, lovely. It's not going to move up or down. Hmm. All right. If you are finished with 8.1 and 8.2, you're welcome to try 8.3 and 8.4. You don't have to wait for us. I'm going to show you my answers to 8.1 and 8.2 now. All right, good stuff, everybody. So I assume that's 8.1 and 8.2 that you guys are finished with. Okay, so in terms of the shape of your function, what shape was your graph? Use words concave down and concave up to describe the shape of this particular cubic function. Okay, so can't just be concave up, Nicole. It's got to be a combination of the two. So either it's concave up and then concave down, or concave down and then concave up. Okay, so you'll see the answer for 8.1 on the screen. You can mark that. Okay, make sure that you show that your second derivative is equal to 0 before you solve for x. Okay, that's really important. Then when you did 8.2, those of you that are finished with that, that's it in Kanyiso. Good. Okay, concave down and then concave up. We know that because the number in front of the x cubed is positive. All right, so again, in 8.2, we've got the x intercepts. I've got 0 and 0 and 3 and 0. So for the coordinate at your other turning point, you would have to make the first derivative equal to 0. Then I'm going to divide through by 3, and then I'm going to factorize. Another thing that's really important, make sure that this line that contains your factors, make sure that it's equal to 0. Don't just write 0 once and then just write equals below and then equals below that. You must show all of these lines are equal to 0. Okay, so x would be equal to 1 or x would be equal to 3. So we know that when 1 went in, 4 came out because we knew that from what they gave us. 3 also happens to be an x-intercept. So we know that that would be 3 and 0. So all that remains for us, let me just move this one down, is for us to draw the function. Okay, I'm going to do that now. Is everybody okay with 8.1 and 8.2? Are there any questions on 8.1 and 8.2 before I go ahead and draw the graph? See, there's a couple of hands up. On Tetile, go for it.
Hi, ma'am.
Hi there, how are you?
I'm good and you, ma'am.
I'm fine, thank you. Do you want to ask a
Ma'am,
question?
ma'am, I'm lost with the first part that you did for 8.2, ma'am.
Okay, so what I was doing here in the first part is I made f of x equal to 0. All right, in order to solve for the x-intercept. So I made y equal to 0. So if you are solving an equation where 0 is equal to x times x minus 3 squared, either x is equal to 0 or x minus 3 squared is equal to 0. So there's two solutions in this case. Either x is 0, or if x minus 3 squared is equal to 0, x would be equal to 3. So those are your x-intercepts.
Ma'am, I get that, but like,
Okay.
why don't you derive first? Why didn't you use
Because
the
I'm
gradient formula for the one?
okay, but the thing is that you've got to be careful on what you're doing, okay? So over here, I don't have to do any particular one first. Over here, sorry, this is me working out the x-intercepts. In the second bit over here, this is me working out the coordinates at the turning points.
Okay. Makes
Okay,
sense.
so this is the TPs. Okay, so often what happens with the matric students is that you get confused between these two questions. So you'll often see when you mark matric scripts that you'll calculate the coordinates at the turning points when they ask you for the intercepts and the intercepts when they ask you for the turning points. Okay, so in question 8.2, they wanted us to sketch the graph. So in order to sketch the graph, I need the x-intercepts, but I also need the coordinates at the turning points. So I knew what one turning point was. I just didn't know what the other turning point was, which is why I did what I did with the pink circle around it.
Okay. Makes sense.
All right.
Thank you, ma'am.
Makes sense. Okay. All right. Zedalia, where you made the first derivative equal to 0, is that the stationary point? Yes. Yes, Zedalia. Okay. So this over here that I'm going to highlight it in purple. This is me calculating the coordinates at the turning points. Okay, so for the coordinates at the turning points, you've got to use the first derivative. Okay, for the x-intercepts you are making, y equal to 0. Okay, so when y is equal to 0, you're calculating the x-intercepts. When your first derivative is equal to 0, you're calculating the x-coordinates at the turning points. Okay, when the second derivative is equal to 0, you're calculating the x-coordinate at the point of concavity. Does that make sense to everybody? Okay, so when y is 0, you're calculating the x-coordinates at the x-intercepts. When the first derivative is equal to 0, you're calculating the x-coordinates at the turning points. When the second derivative is equal to 0, you are calculating the x-coordinate at the point of concavity. So I'm just saying that again. Okay, so now all we need to do is sketch this graph. Okay. All right, so we know that we have got a turning point in the first quadrant. We know our graph has got to go through the origin. So our graph has got to do something like this. It's got an x-intercept and a y-intercept at the origin. It has a turning point in the first quadrant, another turning point on the x-axis, so it will look like that. Okay, this point over here is the point 1 and 4. This point over here is the point 3 and 0. So that's what your graph would look like. Okay, so there is your graph of F. Okay, so just 1 second. I'm just answering a question. Jude, if you have a look up here, all right, now, Jude, this is the restriction with us working online. Can you see that when you sub in 1 into F, you can't get 0, you have to get 4. They gave us this information in the beginning. So the only thing I can think is that you must have subbed in correctly, but try this. So if you've got F of 1, that would be equal to 1 times 1 minus 3 squared. That should give you 4 as an answer. Okay, so they actually gave us the coordinate at the turning point in the beginning. All right. Hope that helps. Pleasure, no problem. Okay, on to 8.3 now. For which values of x will y equals minus f of x be concave down? Right, so let's go and have a look at our graph, and they're talking about y equals minus f of x. So if we consider this, what have they done to f of x to get minus f of x? How do we get minus f of x? What have we done to our graph? What does minus f of x mean? There we go. So we haven't changed the shape in Kanyiso. Pinga, Zedalia, you're on the right track. So if y has changed sign, we must have reflected the graph over the x-axis. Okay, so for y to change sign, the graph has been reflected over the x-axis. I'll just write that here for you. For y to change sign, we must have reflected f of x over the x-axis. Okay, exactly. All right. So is this going to change where our point of inflection is? So let's just have a look. If I was to draw in a sketch in green of what this graph would look like if I reflected it over the y-axis, it would have a turning point down there. It would do that, and then it would do this. That's what it would look like. Okay, so this must be y equals minus f of x in green. Okay. Here is the line, the straight line, I should maybe use this, where x is equal to 2. So this pink line over here is the line x equals 2. All right. your cubic function, when you have reflected it, is now concave up and then concave down, but still at x equals 2. Okay, x equals 2 is still the point of inflection. So if they are asking us for which values of x will it be concave down, it is going to be concave down after x is 2. Does that make sense to everybody? So the answer to this will be where x is greater than 2. Okay, so just having a look at it again, the blue graph is your original graph of f. If they are talking about y equals minus f of x, they have reflected it over the x-axis. Okay, they haven't shifted it up or down or left or right, they've just reflected it. Okay, so that means that your point of inflection is still going to be where x is equal to 2. Your green graph is going to be concave down when x is greater than 2. It will be concave up where x is smaller than 2. Does that make sense? No, so in graphs that don't have asymptotes, there's no restrictions. So there wouldn't be a restriction here. Okay, Pinga. Yeah, so the reason why there would be a restriction on a value that x cannot equal, for example, would be if there was like division by 0 at a particular point. Okay, so if they give you something like g of x divided by f of x, then you would have to disregard values where f of x was equal to 0 because then it would be undefined. Or if we were talking about, say, the domain of a hyperbola, then there would be a restriction on what x could be equal to. If you were talking about the range of an exponential function, then there would be a restriction. Okay. But a cubic function and a parabola, they don't have asymptotes, so you wouldn't have to worry about that. Okay, so Nicole, again, right, the green graph is the reflection of the blue graph over the x-axis. So if f is our graph, our original function, then the green graph y equals minus f of x, because it's a reflection over the x-axis, so y has changed sign. Okay, if you have a look, all right, your point of inflection is still in the same place. Remember, your point of inflection is the point at which the concavity of the graph changes. It's still going to be halfway in between your turning points. So this turning point over here is now 1 and -4. This turning point is still 3. So halfway in between 1 and 3 is still where x is equal to 2. So the graph is now concave down when x is a number that is bigger than 2. Okay. All right. So what's important here is that you are able to do question 8.1, question 8.2. Question 8.3 is complex, right? It's only out of 2 marks. Okay, so don't stress about that one too much. Hopefully the majority of you understand it. Now it says use your graph to answer the following questions. Now these are going to be a little bit more difficult. In 8.4.1, they've said to us determine the coordinates of the local maximum of h if h is f of x minus 2 plus 3. Right? So what does that mean for us? If they tell us h of x is a new function and is equal to f of x minus 2 plus 3. What does that mean? What are we doing to the graph? It's undergoing a transformation. Yes, Pinga, there's no negative marking. You only have that at university. But they may penalize you for, let's say if you do something, let's say they ask you for something that's out of 2 marks, but you don't do it, maybe you have part of the answer and not the other part, then they might penalize you for that. So you can lose marks for things that are incorrect. Antetile, go for it.
Oh no, ma'am, I forgot to put my hand down.
Oh, okay. All right. No problem. Zedalia, your hand's up again?
Yes, ma'am, I'd like to answer.
Sure, go for it.
Sure, go for it.
So, the added 3 is that we're going to shift it 3 units up, and the minus 2 is that we're going to shift it 2 units to the right.
Beautiful. Perfect.
Beautiful.
Okay. All right. Lovely. Okay. So when we minus from x, we are shifting the graph to the right. When we add to x, we are shifting the graph to the left. Okay. So that's really, really important. Okay. So yes, Karabo. Okay. So 2 units right, because when you sub in -2, the act of subbing in -2 actually moves the graph to the right. So you are shifting the graph 2 units to the right and 3 units up. Okay, but they asked us to look at the local maximum. Okay, so here is our local maximum. We're looking at our original blue graph. Here is our local maximum at 1 and 4. They want the coordinates of the new maximum when we have shifted this graph 2 units to the right and 3 units up. So what will the new coordinates be? What do we have to do to 1? We have to add 2 to it. What do we need to do to 4? We need to add 3 to it. So the new coordinates at the maximum, if the graph is shifted 2 units to the right and 3 units up, will be 3 and 7. Okay, and there would be 1 mark on the x and 1 mark on the y coordinate at the new maximum. Okay, so again, this is a complex question. Okay. Yes, the local minimum is at 3. Quite right. Okay. Good, Pinga. Let's have a look at the last question. So Claire claims that f prime 2 equals 1. Do you agree with Claire? Justify your answer. So again, f prime 2 means what? What does f prime 2 mean? What does f prime 2 mean? Okay, not just that x equals 2 in Kanyiso. F prime 2 means the gradient. So in other words, the gradient of f at x equals 2 is 1. Okay. So see how would the 4 came from either subbing 1 into the first derivative, or if you recall up here, f of 1 equals 4. Okay, so we know that there was a turning point at 1. So 4 you would get from subbing 1 back into the original. Okay, Zedalia says you don't agree with Claire. All right, so again, Zedalia, what they would want us to do after we understand the question, what we would now need to do is work out what the answer is, right? So let's work with f prime 2. We're going to sub 2 into the first derivative. So 3 times 2 squared minus 12 times 2 plus 9. So that would be 12 minus 24 plus 9. So that would leave us with negative 12 So that would be -3. So you are right. Claire is wrong. Okay, so the gradient where x is 2 is equal to -3. Okay, it's not equal to 1. Right. Again, if you look at your graph and you look where x is equal to 2, your gradient is negative, isn't it? It's between your turning points. Okay, so there's no ways that the gradient could be positive. That could be another way that you could explain this particular question. Okay, between 1 and 3, the gradient is negative. It cannot be equal to 1. Okay, that would be another way of doing it. Or you could sub it in and actually calculate it as well. I hope so, Zedalia. Okay, any questions before we move on to the next one? Are we all good? Remember, these are being recorded. So if there's stuff that you don't understand, you can come back and watch it again. And don't forget, you've also got the Watobe wizard that you can ask as well. Okay, cool. All right, let's move on and look at the next question. Okay, hopefully we can do all of this before, I almost said before the bell goes. Oh, we're so conditioned to the bell ringing as people at school, aren't we? Okay, so let's just make that a little bit bigger for you guys. Okay, so the sketch below represents the curve of f of x equals x cubed plus bx squared plus cx plus d. The solutions of the equation where f of x equal to 0 are -2, 1, and 4. What does that mean? What are they giving you here? So when f of x equals 0, the solutions to that equation are -2, 1, and 4. What does that mean? What are they telling you? What are these things? Absolutely. Okay, so these are our x-intercepts. Okay, so this -1 over here has to be -2. The smaller positive one has to be 1, and the larger positive one has to be 4. Okay, now the first thing that they want us to do is calculate the values of B, C, and D. Now this relates back to a lesson that I did with you guys. Let's see if anybody knows what it is that we need to do here. What do I need to write here, Matrix? Can you remember? They've given us 3 distinct x-intercepts. How are we going to sub into f of x? What are we going to write? Nicole, go for it.
We're gonna use this formula y is equal to a into x minus x1 into x minus x2 squared.
Okay, so in this case, we're not going to use x minus x2 squared because there are 3 different x-intercepts. So you've got to use
Okay.
this one, x into x minus 3. Okay, but that's very good, Nicole. You know what? It doesn't matter that you got the square wrong. It's really good that you realized that this is what you needed to use. Okay, so never mind about that. That's great. The other bit of information that they've given us is in front of the x cubed, we know that that value is equal to 1. So they are telling us, okay, that a is equal to 1. They've given us this information. So now we can go ahead and go and sub in. We know that it's 1. They've told us that's in the equation. And now we're going to sub in our roots. So it's going to be x plus 2 times x minus 1 times x minus 4. Okay, I'm going to let you guys multiply that out. You tell me what you get. So we need to know the values of B, C, and D.
Sorry, ma'am.
Go for it, Sedalia.
I'm very sorry. I disconnected now because my UPS went off. So I didn't know. I'm a bit confused on how you got A is equal to 1. Is it because of the original equation?
It's
That
because of the original. It's because of the original
okay.
equation. So by them saying to you f of x equals x cubed, they are telling you that the number in front of the x cubed is equal to 1.
Okay.
Okay, so
Thank you,
that's
ma'am.
why I said a is equal to 1. Okay, we can never make an assumption that it is equal to 1, but they're specifying it here in this case, so we're allowed to interpret it as such.
Okay. Thank you so much, ma'am. Sorry.
No problem. Don't say sorry. Anyone got values for B, C, and D yet, please? Okay, thank you, Nkaniso. You're welcome to DM me your answers, Nicole. And Kaniso's done so. And Kaniso, if you want to carry on with the next question, 9.2, go for it.
Okay. My A is 1, B is -8, C is -6, and D is 8.
Okay, all right. Thank you. That's cool. Well done. Okay, so Pinga, I think you got different answers. Just check now. I'm just busy multiplying it out. Ikarabeng. Yes, I'm getting the same answers. Good, Trish. Well done. Okay, so we've done question 9.1. I hope everybody is okay with that. That's not too difficult. In 9.2, got the same answers. Good, Sin and Tlantla. Well done, Trish. And well done in Kanyiso. Okay. Pinga, I hope you're okay and that you have found your mistake if you did make one. In 9.2, calculate the x coordinate of B, the maximum turning point. So we should all be able to do that, okay? So I'm going to let you guys do that as well. The x coordinate, they just want the x coordinate. They don't want the y coordinate. They just want the x coordinate at B. Good, Ikarabeng, that's correct. Okay, so 9.2 you guys are doing by yourselves. They want the x coordinate at B. That's good, Ikarabeng, that's perfect. Okay, you got the right answers. Okay, all right, Pinga. Oh, it's okay, Humutso. We're busy doing this question now. Probably a good idea for you to watch the video, okay? Again, when you've done 9.2, you can DM me or Yolanda. Let us know what your answers are. Okay, so Zedalia and Katlejo, be careful. B is in the second quadrant. So Sihle, your sign is correct, but your value is wrong. Sinenhlanhla can't be positive. Okay, remember B is in the second quadrant where X is negative. Okay, so for 9.2, because we're talking about a maximum, we're talking about a turning point, we've got to use the first derivative. There we go. Ruth, good. Okay. So Sinenhlanhla and Hlafaso, you've got the same answers. That's really interesting. Zedalia?
Sorry, ma'am, I feel bad for speaking so much because I know everybody's working. But
That's okay.
I'm a bit like confused because when they say the maximum turning point, I use the turning point formula, negative b over 2a.
No, you can't do that because it's not a parabola.
Oh, okay.
Okay. So you can do that for a parabola, but you can't do it for a cubic function. For a cubic function, you've got to use the
First derivative.
first derivative.
Thank you very much, ma'am.
No problem. Okay, so here, this is not going to factorize. Sorry, I was just thinking about this. Okay, so Eve, how did you get -1? Okay, so let's do 9.2 together. That's fine. All right, so here's 9.2. For the maximum turning point, we've got to use the first derivative. Okay, so we know that f of x is equal to x cubed minus 3x squared minus 6x plus 8. That means our first derivative here in blue on the right-hand side is 3x squared minus 6x minus 6. We've got to make it equal to 0 because we're calculating the coordinates at the turning point where the gradient is 0. If we divide through by 3, we would end up with x squared minus 2x minus 2. Now, looking at that now, that is not going to factorize. Okay, it's not going to factorize. So it means we would have to use the quadratic formula. So x would be equal to negative b plus or minus b squared minus 4ac all over 2a. All right, so you guys would need to pop that into your calculators. Sorry, I can't see because I'm sitting in the dark here. Let me just turn my flashlight on. But yes, I think those of you that are getting that fraction answer, that is going to be correct. Yes, so I'm also getting negative 0.73. Where's my pen gone? There we go. Let's just see what's going on in the chat here. That's it. Good, well done. You could leave your answer in third form. That's fine. Or you can, it doesn't matter, Pinga, you can leave it in third form, doesn't matter. Or you can write it as a decimal. Okay, so here x is equal to negative 0.73. Okay, it's important that it is negative. Okay, Ruth, you were making a mistake when you were differentiating. Zedalia, not sure how you got negative 0.22. Just check how you subbed in. So whether you use 3 minus 6 and minus 6, or whether you use 1, negative 2, and negative 2, you should get the same answer. Okay, so we've got the x coordinate at B. I think we're only going to have time for one more question. Is everybody okay so far? All right, so let's do 9.3 quickly, and I think we're going to have to leave it there. I can always, oh, you've got the form from the formula. Okay. Yeah, so just be careful when you're using your quadratic formula. All right. Now it says determine an equation for the tangent to the graph at x equals negative 1. Okay, so what they are giving us is the x coordinate at the point of tangency. Right. So when you are calculating, let's just move this guy totally out the way. When you are calculating the equation of a tangent, you need the gradient of the tangent, you need the x coordinate at the point of tangency, and you need the y coordinate at the point of tangency. They have told you that the x coordinate is negative 1. It's easy enough to work out the y coordinate because that would be f of negative 1. So if we sub that into our original equation, it would be negative 1 cubed minus 3 times negative 1 squared minus 6 times negative 1 plus 8. So that would give us negative 1 minus 3 plus 6 plus 8. So that would be 10. Okay, so we know what the y coordinate at the point of tangency is. In order to get the gradient at the point of tangency, we have to sub negative 1 into our first derivative. So f prime negative 1 equals 3 times negative 1 squared minus 6 times negative 1 minus 6. This leaves us with 3 plus 6 minus 6, which leaves us with 3. Okay, so subbing into y equals mx plus c, the equation of a tangent, y is 10 when the gradient is 3, when x is equal to negative 1. So that means that c would be equal to 13. So the tangent would be y equals 3x plus 13. I hope I didn't do that too quickly. Are there any questions before we say goodbye? I see there's a couple of people with hands up. Let's just see. Sihle, I think you had your hand up earlier. Sihle, go for it. Unmute and speak.
Hey, ma'am.
Hi, Sihle.
Can you please explain to me the empty equals the empty stuff, the x emptied and the y empty, please?
All right, fine. So if they want the equation of, oopsie, I'm drawing in pink here and it looks terrible. Okay, if they want the equation of a tangent, Sihle, they want it in the form y equals mx plus c. So you need the y, you need the m, and you need the x because you're always going to have to calculate the c value. So the m is the gradient of the tangent. The x is the x at the point of tangency. The y is the y at the point of tangency. Okay, so they told us that it was a tangent to the function at x equals minus 1. So in order to get the y coordinate at the point of tangency, we are subbing f of 1 into our original. So this is subbing -1 into f of x to get the y coordinate at the point of tangency. Then we also have to sub -1 into f prime -1 to get the gradient when x is equal to -1, that's 3. So that's why I've said the gradient at the point of tangency is 3. We know that the x coordinate at the point of tangency is -1. We know that the y coordinate at the point of tangency is 10. So that's why I'm putting the 10 here where the y is, the 3 in place of the gradient, the -1 in place of the x, and I'm working out the value of c. Okay, Mbuso, did that make sense? I'm sorry, I know I did that a little bit quickly.